this is part 6 of topic 2, Kinematics 2D motion, which is going to be focusing mostly on projectile motion. We're going to talk about projectiles launched horizontally, and then also projectiles launched at an angle. So you're going to use the kinematic equations that you learned in topic 2, Kinematics 1D motion, such equations as like VF squared equals VI squared plus 2G delta Y. Also delta x equals vi delta t plus 1/2 g delta t squared, vf equals vi plus at, those equations. So you're going to be using them again, but now you're going to have to use 2 of those equations in one problem because the objects will be utilizing both the x and the y axes simultaneously, right? So you can't just use one of the kinematics. You're going to have to use 2 of the kinematics. Furthermore, guys, please get this straight. You're going to have to use the x-axis to solve for the y-axis, or you're going to have to use the y-axis to solve for the x-axis. So like ultimately the question is going to ask, so how high was the cliff? Well, ultimately then you want delta y equals blah, blah, blah. So that means you're going to have to use a delta x equation to most likely solve for time that you can then plug into the delta y equation so that you can solve for delta y. So if it's 2D motion, you're going to have to use 2 kinematics. Now the difference is going to come in where a projectile is launched horizontally, it's just that. And we'll go over those equations in a second, exactly what I just now explained to you. Okay, so the second half is going to be on projectiles launched at an angle. So it's going to be the same exact equations again, but now that you're being launched at an angle, you have to also include, initially you're going to be launched at an angle, right? So your VI is what we want to hone in on here. So you're going to have to include either cosine theta, moving in the x-axis, or sine theta, moving in the y-axis. So you have to be more specific and say VFY squared equals VIY squared sine theta squared plus 2g delta y. That kind of a thing. Okay, so we'll see here in a second. One thing that I want you to look at now is for now, and IB will get further into it, but for now you're going to disregard air resistance. And checking out this diagram here, you can see the difference between 2D motion, the yellow ball, is falling down and over at the same time because it was given an initial horizontal velocity. And then the red ball would be just 1D motion. It was dropped straight down. Okay? So the analogy here is you roll, not kick, because kick would be an initial horizontal, or I'm sorry, an initial velocity which would make you launch at an angle, but let's say you roll a ball off the top of a cliff and it's soaring down towards the ground. It was rolling outward, right? So it's going to want to go out, but the force of gravity is going to be pushing it down at the same time. So therefore you are utilizing your x, outward, and y, force of gravity, axes simultaneously. Thus the yellow ball in this example, or the ball that was rolled off of the cliff, is utilizing 2D motion. Okay, let's move into this. So the equations that you want to look at for vertical motion when you're starting from rest. Now, once again, I've stated you're going to use the same exact equation, so don't write this down yet, just watch it. So initially you have VF in the y direction equals VI in the y direction plus G delta T. Well, if you're starting from rest, that means what about your VI, like for every equation, guys? What would VI be? Give me a numerical value for VI if you're starting from rest. Well, if you're starting from rest, so that means that VI equals 0 meters per second. So that's why we're just going to hack that out of there. So don't look at these as though like, what the heck, I thought she said it was the same equations over again. It is. It's just don't write the VI because it's 0. Save yourself some time there. Okay, so instead of VFY equals VIY plus G delta T, you're just going to simply write VFY equals G times delta T, whereas your G is 9.81 meters per second squared, but don't forget to assess direction with it as well. And obviously we're going to use Y instead of X because we're moving up and down, not left and right. The second equation that I want you to look at is VF in the Y direction squared equals 2G delta Y. Remember it was originally VF squared equals VI squared plus 2G delta Y. Well, if the VI is 0, 0 squared is 0. So just hack it off there. Therefore, number 2, VF in the y direction squared equals 2G delta Y. All right, and then lastly, delta Y equals, you would think, VI delta T plus 1/2 G delta T squared, but VI, 0, times delta T, regardless of what the number is, would be 0. So VI delta T becomes nothingness. So your new equation is delta Y equals 1/2 G delta T moving horizontally. You just have one equation that you have to worry about here. Delta x equals v sub x, the velocity in the x direction, times delta t. So these are the four equations that you're going to use if the problem says an object is launched horizontally with an initial velocity of blah, 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 blah. Hopefully it says from rest, you just put it as 0. But if it doesn't say from rest, then please understand that you need to insert the VI into these. Okay, moving right along. So solving for these sides, what you really want to do is you want to use sine theta for the y component if you're dealing with a bow tie triangle. Use the cosine theta for a y component if you're using an hourglass triangle. Use cosine for the x if it's a bow tie. Use sine for the x if it's an hourglass. Use the Pythagorean theorem for magnitude, and use the trig function for direction. Usually inverse tan, but know your x and your y. Because once again, if it's a bow tie, it's going to be theta equals the inverse tan of y over x. And if it's an hourglass, it's going to be theta equals the inverse tan of x over y. I'm running out of room, but I think you understand what I'm saying by now. Okay, moving right along. Next one we have is, okay, so a golf ball is struck with a club at a velocity of, with an angle of, that kind of a problem. So now you're going to use the same kinematics again, guys. They're not going anywhere. It's just now you have to include the trig function, either sine or cosine, with your x and your y's initial velocity. So if you're saying delta x equals, then it needs to be vi cosine theta. If you're saying delta y equals, then it needs to be vi sine theta. Makes sense? Check out the triangle here. You can see that the y direction is opposite theta. So if you're opposite theta, think about so, ka, toa, and that would mean that your y is therefore the sine function. Whereas your x, okay, check that out, theta in relationship to x, that would be ka, right? Adjacent, and then obviously the hypotenuse, so the resultant side would be given to you. So that would be the cosine theta function. Okay, so our original equations are over here in blue. What do you have to do to turn these original equations into projectiles launched at an angle? Once again, Miss Arter said, I said you gotta include either the cosine function or the sine function with the initial velocity. So let's rewrite number 1 again. Number 1 is now going to be delta x equals vi, and hopefully you got that, cosine theta times delta t. All right, let's look at the next one. Vf equals Vi, well, I don't know, is it supposed to be cosine or sine? Check that equation out, guys. What is like the blaring, make me this trig function because I'm present? It should be your acceleration due to gravity. If you're using acceleration due to gravity, clearly which direction are you headed in? Either up or down, right? So you're utilizing the y-axis right there. So technically, Vf sub y equals Vi sub y sine theta. So you'd want to put sine theta in here, plus g times delta t. All right, number 3. Vf squared equals Vi squared plus 2g delta y. Well, that's a dead giveaway that you want to use the delta y, so therefore it should be the sine function because it says delta y right into it. But also g is in there. So this new equation is Vf squared equals Vi squared sine theta squared plus 2g delta y. And number 4, this new equation is going to be delta y equals Vi cosine theta times delta t plus 1/2 g delta t squared. Make sense? You're going to apply them to problems, but okay, I get it. If I'm moving in the y direction, then I need to make it sine theta, check that out, and if I'm moving in the x direction, then I need to make it cosine theta. Whoa, 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 Miss Arter. You guys should see a big flaring arrow that is wrong here, right? So you don't want cosine theta right here, correct? Yeah, you want sine theta there instead because you're moving in the y direction. So this really should say delta y equals Vi sine theta delta t. Yay! Okay, now let's actually try this. 2D motion means x and y equations, so that means you want to use an x equation to solve ultimately for a y unknown, or you want to use a y equation to solve for the ultimate x unknown variable. So the Royal George Bridge, yes, the Royal Gorge Bridge in Colorado rises 321 meters above the Arkansas River. Suppose you kick a rock horizontally off the bridge. The magnitude of the rock's horizontal displacement is 45.0 meters. Find the speed at which the rock was kicked. So what do you know going into this problem? Let's check it out. You know that you have a delta y, right? Okay, well, it's clearly 321 meters, but is it a positive or a negative? What's the rock doing? Is the rock going up in the air, or is it coming down to the ground? Okay, so it's coming down to the ground, so that should be a negative 321. It also tells you that it's heading outward at 45.0 meters. Oh, look, we're falling down to the ground, so a negative 9.81 meters per second squared. And then ultimately you want to solve for your velocity that you kicked the rock with, right? Find the speed with which the rock was kicked. Well, how did you kick it? You kicked it horizontally, so v sub x, right? And technically it's let me rewrite that real quick. It should be vi in the x direction or vx in the I direction. Initial velocity in the x direction is going to be measured in meters per second. Okay, so ultimately you're trying to figure out a x value, right? So you want to start with a y equation. Assess your givens here. What do you have that you need for this x equation? Well, what you need for the x equation, let me just jump to the point here. There's only one for horizontal, right? Like flip back to the slide. Look at this real quick, guys. There's only one equation that is showing you horizontal motion. So that's the one that you want to write out. Okay. So what we really have here is delta x equals vix times delta t. And you want to ultimately rearrange it so it says delta x over delta t equals vix. Make sense? Okay, cool. So something that's missing here is time. So that means you want to use a y equation to solve for time and then plug that value into your x equation. So find me a y equation that has your acceleration due to gravity and time in it. And you know your y direction is going to be 0. So that equation should be delta y equals 1/2 g delta t squared. So we really have delta y times 2 divided by g, square root of that equals delta t. Make sense? Multiply by 2, divide by g, take the square root, so you get just t. Okay, let's plug in. So that would be the square root of 321, remember it's just a direction. Don't get hung up on, oh, I can't take the square root of negative numbers. Yeah, I know that. That's math class. This is physics. So 321 times 2 divided by 9.81. Oh, well, anyways, check that out. My solder, it doesn't really matter. Those are going to cancel each other out. So 321 times 2 divided by 9.81 equals square root second answer equals. Now, from that, you should get a value that is 321 times 2 divided by 9.81 equals square root second answer, roughly about 8.08. And we need one more, 8.089 is what you should be seeing there. So that's going to give you 8.09 seconds for delta t. It's not a final, but we want to use that right there. Okay, so now let's plug in down here, and I'm just going to write this over here to the right, guys. So this is going to be 45.0 divided by 8.09 equals. So 45 divided by 8.09 is going to give you 5.562. And you only want 3 sig figs. The 2 does not round the 6 up, so therefore your final answer is going to be 5.56 meters per second equals vix. Box it and move on. Okay, we're going to have to stop right there on this one. So I will do a quick video with the projectile launched at an angle. All right, so tune in here to part 7 for projectiles launched at an angle. This was just projectiles launched horizontally.